Download this code from codegive.com, link in the description below. OK, let's dive deep into JSON Web Tokens, JWTs. This tutorial aims to give you a comprehensive understanding, covering the fundamentals, security aspects, system design considerations, and practical code examples. What are JSON Web Tokens, JWTs? JWTs are a compact, URL-safe means of representing claims to be transferred between two parties. Claims are statements about an entity, typically, the user, and can be used to determine access rights, identity verification, or any other information relevant to the application. JWTs are digitally signed using a secret, with the hmac algorithm, or a public/private key pair using RSA or EXA. Key characteristics *** compact * due to their smaller size, JWTs can be easily transmitted through URL query parameters, post parameters, or HTTP headers. Self-contained ** a JWT contains all the necessary information about the user. No database lookup is required on every request, which can improve performance. However, this also means the size can grow with more claims. URL safe JWTs are designed to be easily encoded for safe transmission in URLs. Stateless servers do not need to store session information, making them inherently scalable. Versatile JWTs can be used for authentication, example verifying the user's identity, and authorization, example granting access to specific resources. 2. JWT structure. A JWT consists of three parts, separated by periods. 1. Header * contains metadata about the token, such as the type of token, JWT, and the signing algorithm being used, example HS256, RS256. 2. Payload * contains the claims, statements, about the entity, user, and additional metadata. 3. Signature * ensures the integrity of the JWT. It's created by taking the encoded header, the encoded payload, a secret, or private key, the algorithm specified in the header, and signing it. JWT structure in detail *. 1. Header ***. The header is a JSON object that usually contains two parts. *alg, the algorithm used for signing the token, example HS256, RS256, ES256. *tip, the type of the token, which is JWT. Example. This header is then base64 URL encoded. 2. Payload ***. The payload contains claims, pieces of information, about the user and / or the token. There are three types of claims. Registered claims *, predefined claims like ISS, issuer, subject, AUD, audience, EXP, expiration time, NBF, not before, IAT, issued at, and JD, JWT ID. These claims are optional but recommended. Public claims * claims defined by the application developer. They should be registered in the IANA JSON Web Token Registry or be collision resistant, example use a URI. Private claims * custom claims defined by the parties using the JWT. Use these with caution because they can increase the size of the token. Example. This payload is also base64 URL encoded. 3. Signature ***. The signature is used to verify that the sender of the JWT is who it says it is and to ensure that the message wasn't changed along the way. Asterisk the signature is computed as follows. Asterisk for hmac, example HS256. Asterisk for RSA or exa. The secret, for hmac, or privat key, for RSA/exa, is known only to the server that creates and signs the JWTs. Never share the secret or privat key with the client. Example JWT asterisk. Asterisk header asterisk EYJHBXOJI as I1 NI is in R5CCI6 ICPEX VCJ9, base 64 URL encoded JSON. Asterisk payload asterisk EYJZDW209MJM0NTY30DKW WIBMFTZSI6 SICPG4GRG9 LUIA WF0I Jokesen TE2MJM5MDEVQ, base 64 URL encoded JSON. Asterisk signature asterisk SFLKXWRJSMEKKF2QT4FWPMEJF36 POC6YJV underscore at QSSW5C. You can easily decode and inspect JWTs using online tools like jwt.io, https://jwt.io. 3. JWT authentication flow. The typical JWT authentication flow works as follows. 1. User login asterisk the user provides their credentials, example username and password, to the server. 2. Authentication asterisk the server verifies the user's credentials against a database or other authentication system. 3. JWT creation asterisk if the credentials are valid, the server creates a JWT containing claims about the user, example user ID, roles. The server signs the JWT with its secret key. 4. JWT transmission asterisk the server sends the JWT back to the client, example in the response body, as a cookie, or in a custom header. 5. JWT storage asterisk the client stores the JWT, example in local storage, a cookie, or in memory. 6. Request with JWT asterisk for subsequent requests to protected resources, the client includes the JWT in the authorization header, typically using the bearer scheme. 7. JWT verification asterisk the server receives the request with the JWT. It extracts the JWT from the header and verifies its signature using the server's secret key. 8. Authorization asterisk if the signature is valid, the server can trust the claims in the JWT. It can then use these claims to determine if the user is authorized to access the requested resource. 9. Resource access asterisk if the user is authorized, the server processes the request and returns the requested resource. 10. Token refresh, optional since JWTs have a limited lifespan, expiration time, you'll often implement a refresh token mechanism. The client sends a refresh token to the server, which verifies the refresh token and issues a new access token, JWT, and a new refresh token. 4. System design with JWTs. Let's consider a system with a front-end, client, a backend API server, and a database. Components asterisk. Asterisk front-end, client a web application, example React, Angular, Vue.js, or a mobile app. Asterisk backend API server asterisk a server-side application, example Node.js, Python/Flask, Java/Spring, that exposes APIs. Asterisk database asterisk stores user credentials and other application data. Design considerations asterisk. Asterisk authentication endpoint asterisk the API server should have an endpoint, example /login, for user authentication. Asterisk JWT generation asterisk the API server is responsible for generating JWTs after successful authentication. Asterisk JWT storage asterisk the client needs to store the JWT securely. Common options are HTTP only cookies. The most secure way to store JWTs in the browser. HTTP only cookies are inaccessible to JavaScript, which prevents XSS attacks from stealing the JWT. The browser automatically sends the cookie with each request to the same domain. However, this makes it vulnerable to CSRF attacks if not implemented carefully. Local storage relatively easy to implement, but vulnerable to XSS attacks. If an attacker can inject JavaScript into your site, they can access the JWT stored in local storage. Session storage similar to local storage, but the JWT is cleared when the browser tab or window is closed. In-memory storage store the JWT in a JavaScript variable. The JWT is lost when the page is reloaded. Authorization middleware the API server needs middleware to verify the JWT on protected routes. Token expiration JWTs should have a reasonable expiration time, example 15 minutes, 1 hour, to reduce the window of opportunity for attackers to use stolen tokens. Refresh tokens use refresh tokens to allow users to stay logged in without having to re-enter their credentials frequently. Refresh tokens are long-lived and stored securely on the server. Token revocation implement a mechanism to revoke JWTs, example if a user logs out or if a token is compromised. This typically involves storing revoked token IDs in a database or cache. Security use HTTPS always use HTTPS to protect JWTs from being intercepted during transmission. Protect secret key keep the secret key used to sign JWTs secure. Do not hard code it in your application. Store it in an environment variable or a secure configuration file. Validate claims always validate the claims in the JWT, example expiration time, issuer, audience, to ensure that the token is valid. Prevent cross-site scripting, XSS implement measures to prevent XSS attacks, as they can be used to steal JWTs. Prevent cross-site request forgery, CSRF if using cookies for JWT storage, implement CSRF protection. Avoid storing sensitive data in JWTs. Do not store sensitive data like passwords or credit card numbers in JWTs. Remember that the payload is only base64 URL encoded, not encrypted. vCode example, Node.js with Express and Json webtoken library. Here's a basic example of how to implement JWT authentication in Node.js using Express and the Json webtoken library. Explanation 1 Dependencies installs Json webtoken for JWT handling and bcrypt for secure password hashing. Install them using npm install Json webtoken bcrypt. 2 Secret key A secret key is used to sign the JWT's important in a real application. You must store this key securely using environment variables or a configuration file. Do not hard-code it in your application code. 3 User database a mock users array is used to simulate a database. In a real application, you would use a database like MongoDB, PostgreSQL, or MySQL. 4 Register root handles user registration. It hashes the password using bcrypt before storing it in the database. 5 Login root handles user login. It verifies the user's credentials by comparing the provided password with the hashed password stored in the database. If the credentials are valid, it generates a JWT using the Json webtoken library. The JWT contains the user ID and username. 6 Authenticate token middleware *. This middleware is used to protect routes that require authentication. It extracts the JWT from the authorization header, verifies it using the secret key, and attaches the user information to the request object. 7. Protected root *. The /protected root is protected by the authenticate token middleware. Only authenticated users can access this root. The root handler retrieves the user information from the request object and returns it to the client. How to run the example *. 1. Save the code to a file, example app.js. 2. Install the dependencies, npm install express json wetoken bcrypt. 3. Run the server, node app.js. You can then use a tool like Postman or curl to test the API. Register a user *. Login *. This will return a JSON response containing the JWT. Access the protected root *. Replace JWT with the actual JWT you received from the login endpoint. 6. JWT Security Best Practices, Recap and Emphasis. Use HTTPS *. Absolutely essential to protect JWTs in transit. Secure secret key *. Protect the secret key used for signing the JWTs. Store it securely, never hard-code it, and rotate it periodically. Use strong, randomly generated keys. Short expiration times. Use short expiration times, example 15 minutes to 1 hour, to limit the impact of compromised tokens. Implement a refresh token mechanism. Validate claims. Always validate the claims in the JWT, example exp, ISS, AUD, to ensure that the token is valid and legitimate. Token revocation. Implement a mechanism to revoke JWTs. This can be done by storing revoked token IDs in a database or cache. Input validation. Thoroughly validate all user input to prevent injection attacks that could lead to JWT compromise. XSS and CSRF protection. Implement measures to prevent XSS and CSRF attacks, especially if you are storing JWTs in cookies or local storage. Principle of least privilege. Grant users only the permissions they need to perform their tasks. Use claims in the JWT to enforce these permissions. Avoid storing sensitive data. Do not store sensitive information in JWTs. The payload is only base64 URL encoded, not encrypted. Consider alternatives to JWT for sessions. While JWTs are useful for stateless authentication, traditional server-side sessions might be more appropriate in some scenarios, especially when revocation is critical. Monitor and audit. Implement logging and monitoring to detect suspicious activity related to JWTs, example excessive login attempts, invalid tokens. 7. Refresh tokens, elaboration. Refresh tokens are used to obtain new access tokens, JWTs, without requiring the user to re-enter their credentials. The process typically involves the following steps. 1. Initial login. After the user successfully authenticates, the server issues both an access token, JWT, and a refresh token. 2. Storage. The access token is stored on the client, example in local storage or a cookie. The refresh token is stored securely on the server, example in a database, and associated with the user. 3. Access token expiration. When the access token expires, the client makes a request to the /refresh endpoint on the server, sending the refresh token. 4. Refresh token verification. The server verifies the refresh token. This involves checking if the refresh token is valid, not expired, and associated with a valid user. 5. New access token issuance. If the refresh token is valid, the server issues a new access token, JWT, and a new refresh token. The old refresh token is often revoked or invalidated. 6. Client update * the server sends the new access token and refresh token back to the client. The client replaces the old access token and refresh token with the new ones. Benefits of refresh tokens * improved user experience * users don't have to re-enter their credentials frequently. * enhanced security * access tokens have a short lifespan, limiting the impact of compromised tokens. * token revocation * refresh tokens can be revoked, providing a way to invalidate access tokens. 8. Conclusion. JSON web tokens are a powerful tool for implementing authentication and authorization in modern web applications. However, it's essential to understand the security implications and follow best practices to protect your applications and users. This tutorial provides a solid foundation for working with JWTs, but always continue to learn and stay up to date with the latest security recommendations. Remember that security is an ongoing process, not a one-time fix.